Now we are going to study about the stagnation properties and we are going to derive an expression for a stagnation pressure. Now, when we call a properties as a stagnation, right, that means the fluid is flowing or a fluid is passing across the immersed body, and at some point the body resultant velocity will becomes zero, right. The value of pressure, temperature, density, etc. at that point is called as a stagnation properties, right? And that point is called as a stagnation point. Let us consider one example. We have a body like this, and fluid is flowing across this body like this, flowing like this here. Right. At one point, the properties, at one point, the velocity becomes zero there, right? And there is an increase in pressure, there might be increase in temperature, there might be increase in density, or it might decrease there. That property is called as a stagnation property. Let us say this point 2 is called as a stagnation property, and point 1 is the point where the properties are flowing there, or the fluid is flowing there, right. The point 2 is called as a stagnation point. The values of pressure, density, etc. at this point is called as a stagnation pressure, stagnation density, stagnation temperature, etc., right. And it is denoted by, like, ps is a stagnation pressure, rho s is a stagnation temperature density, and ts is the stagnation temperature there, right. Now to find out this stagnation pressure, expression for stagnation pressure, what we have done, we have considered a compressible fluid passing in an immersed body there, right. This is the body what we have considered here, and fluid is passing around it, right. It is an frictionless adiabatic condition. We are considered as frictionless adiabatic condition, and we have p1, rho1, T1 are the pressures, temperatures, and densities at this pressure, density, and temperature at point 1. Similarly, P2, rho 2, and T2 are pressure, density, and temperature at the point 2. Right. Now, what we do? We apply the Bernoulli's equation for an adiabatic condition. Now, applying the Bernoulli's equation for adiabatic condition, we have gamma divided by gamma minus 1 into P1 by rho g, rho 1 g1, rho 1 g plus V1 square by 2g plus Z1 is equals to gamma divided by gamma minus 1 into P2 by rho 2g plus V2 square by 2g plus Z2. This is the Bernoulli's equation what we have considered. This is the Bernoulli's equation for adiabatic condition here. Now, as we can see, we have considered Z1 is equals to Z2 there, right. So, the equation becomes gamma divided by gamma minus 1 P1 by rho 1g plus V1 square by 2g is equals to gamma divided by gamma minus 1 P2 by rho 2g plus V2 square by 2g here, right. Now, at this point 2 is the stagnation point there, right. So, what happens? The velocity will becomes 0 at 2. The velocity v2 will be 0 there. So, when the velocity v2 is 0, the pressure P2 will be equal to PS, stagnation pressure, and density rho 2 is equals to rho S here, that is stagnation density there. So, we will be substituting in the above equation. So what we will get? We will get gamma divided by gamma minus 1. I'll use brackets, and P1 by rho 1g plus V1 square by 2g is equals to gamma divided by gamma minus 1 into Ps by rho s g plus 0 there. I won't, no need to write that one. I'll stop till here. Right. Now after that, what I'll do, I'll take out the common terms. We have gamma divided by gamma minus 1 and gamma divided by gamma minus 1 in these two expressions. So I'll take out gamma common here. Gamma divided by gamma minus 1 into P1 by rho 1 g plus minus, this becomes minus here, Ps by rho s g is equals to minus V1 square by 2g here. So g I'll get cancel, I'll cancel it out. Remaining will be gamma divided by gamma minus 1 P1 by rho 1 minus Ps by rho s is equals to minus V1 square by 2 here. Right. Now in this term, I'll take out gamma divided by gamma minus 1. I'll take out P1 by rho 1. Remaining will be 1 minus P 1 minus Ps divided by rho s into rho 1 divided by P1 here is equals to V1 square by 2. Right. Now I'll call this as equation number 1. What is the equation number 1 I have got? I'll write it once again. I have gamma divided by gamma minus 1 into P1 by rho 1 minus into P1 by rho 1 1 minus Ps by rho s, Ps divided by rho s into rho 1 divided by P1 is equals to minus V1 square by 2. Right. This is the equation what we have got here. Right. But for an adiabatic process, we have that is P by rho raised to gamma equals constant. Right. This is what we have, or else I can write P1 by rho 1 raised to gamma is equals to Ps by rho s raised to gamma here. Right. Now in place of P1 by rho s, I'll substitute it as in rho 1 by rho s, and I'll substitute it as P1 by Ps here. Right. So for that I need to do rho 1 divided by rho s. Right. So I taken this on the other side, raised to gamma, I'll write it here, rho 1 by rho s raised to gamma is equals to P1 by Ps, or else I can write rho 1 by rho s is equals to P1 divided by Ps raised to 1 divided by gamma here. Right. So I have rho 1 by rho s here. I'll substitute that as P1 by Ps there. Right. Now substituting this in, I have called this as equation number 1. Substitute rho 1 by rho s in equation number 1. I'll get gamma divided by gamma minus 1, and we have P1 by P1 by rho 1 into 1 minus Ps divided by P1 into P1 by Ps raised to 1 divided by gamma here, right, which is equals to minus V1 square by 2. Right. Now what I'll do, uh, now I'll multiply these terms inside the brackets, right. So what I'll get, I'll get gamma divided by gamma minus 1 P1 by rho 1 into 1 minus Ps divided by P1, right, raised to 1 minus of 1 divided by gamma. What I have done, in this here is I have taken the reciprocal of this one. So when I take reciprocal, this becomes negative. So I'll get in terms of Ps by P1 there. So P, as the denominators are same, I can add up the numerators, right. Ps by P1 into Ps by P1 raised to minus 1 divided by gamma. So I'll get in terms of, oh, I can add up that. So I get 1 minus 1 divided by gamma into V1 square. This is the expression what I'll get. Right. Now what I'll do, we'll take out these terms in the opposite side. Right. So I'll get 1 minus Ps divided by P1 raised to 1 minus 1 divided by gamma is equals to, I'll get minus V1 square by 2. This term becomes gamma minus 1 divided by gamma into rho 1 by P1 here, right. Now what I'll do, I'll take this term in opposite direction and V1 expression in here. So I'll get 1 plus V1 square by 2 into gamma minus 1 divided by gamma into rho 1 by P1 is equals to Ps divided by P1 is to 1 minus 1 divided by gamma here. Right. Now what I'll do, now for an adiabatic process, the velocity of sound is given by the expression. Now the velocity of sound for adiabatic process we have C is equals to square root of gamma r t, right, or else I have in terms of gamma into P by rho, right. This is what the velocity of sound we have, right. Now I'll take that expression, that is C square is equals to gamma into P by rho there, right. So in place of this one P by rho, right, in place of this gamma into P1 by rho 1, I can substitute that as C1 here, right, P1 by rho 1. Now I'll call the last equation as equation number 2 there, right. I'll call this as equation number 2. Now I'll substitute this, the value of gamma into P1 by rho 1, where we have, this is the expression what we have here. I'll be replacing that by C1 square there. So I'll get 1 plus V1 square by 2 into gamma minus 1 divided by C1 square is equals to Ps by rho s right? Ps by P1, sorry, Ps by P1 here into 1 minus 1 divided by gamma here, right? After this, what I'll do, I'll write in terms of Mach number there, right? Now, what is Mach number we have? Or else I can write, I'll write this one as 1 plus V1 square by 2 C1 square into gamma minus 1 into is equals to Ps divided by P1 raised to 1 minus 1 divided by gamma, right? Here you can see V1 by C1, right? C1 by V1, that is C by V, that is the velocity of a projectile, velocity of sound divided by velocity of projectile divided by velocity of sound is nothing but the Mach number there, right? Now in place of that we have velocity of the projectile V and velocity of sound C there. In place of that I can substitute it as a Mach number m. So I can write that as 1 plus m1 square divided by 2 into gamma minus 1 is equals to Ps divided by P1 is to I'll multiply this as gamma minus 1 divided by gamma. What I have done, I have taken the common term, that is this one LCM there, right? After that I'll write Ps divided by P1 raised to gamma minus 1 divided by gamma is equals to 1 plus gamma minus 1 divided by 2 into m square here, right? Or else I can write this as Ps divided by P1 is equals to 1 plus gamma minus 1 divided by 2 into m square whole raised to gamma divided by gamma minus 1. Or else I can write this as Ps is the stagnation property, which is equals to P1 into 1 plus gamma minus 1 divided by 2 into m square whole raised to gamma divided by gamma minus 1, right? This is the expression for stagnation pressures, right? Thank you.